Okay, good morning everyone. We will start now. So the chapter that we are going to start today is binomial theorem. I hope all of you have studied something like a plus b whole square, a plus b whole cube, right? And are aware of what is the meaning of binomial, right everyone? Tell me. Yes? So this was quite easy, right? When someone asked you, okay, what is the formula of a plus b whole square or a plus b whole cube? You could have just said, right, a square plus 2ab plus b square, or a cube plus b cube plus 3a square b plus 3b square a, right? Just by multiplying. But what if we have multiple powers, right? If instead of having a plus b whole square or a plus b whole cube, if I'm having a plus b to power 7 or a plus b to power 8, right? Now, in that case, it will become difficult to multiply. Yes or no? Tell me. Yes or no? Right, everyone? Okay, I hope all of you agree that it will become difficult to multiply. Then how to find those values, right? Then how to find those values? Or suppose you have to find the value of 999 whole 6, right? So is there any easier way to do this, right? Or 98 to the power 2. I hope 98 to power 2 we all have solved in our junior classes, as 98 square is equal to 100 minus 2 whole square. I hope all of you remember this in our junior classes, right? Class 8 square and square roots. Ring a bell? Yes? Yes or no? Right? So what I want to know is, I want to know a general formula, right? If I can write a plus b, which is a and b can be a variable to the power n, right? How can I write this? Okay, how can I write this? Now, before going through the formula, let's understand what is the meaning of that, right? Now, let's start with a plus b whole square. Okay, so when I'm saying a plus b whole square, right, isn't it a plus b into a plus b? Okay, everyone, this is a plus b into a plus b. I hope everyone is getting this. Yes? Okay, now if it is a plus b into a plus b, right, instead of multiplying, let's have a different approach. Okay, because when you're multiplying, what you're doing, you're choosing the variables, right? Yes or no? Think about it. You're choosing the variables to multiply. Got it? Right? So instead of just thinking is as a multiplication problem, just think as a problem in which we have two baskets, right? Suppose we have two baskets, right? This is basket one, this is basket one, okay, and this is basket two, this is basket two, right? And this is apple and this is banana, suppose. Okay, think about it, right? And in second basket also we have one apple, one banana, right everyone? Right? Now suppose you have to choose, right? And the condition here is you have to choose two fruits at a time. You have to choose two fruits. Okay, got it? You have to choose two fruits, but both the fruits should be from different baskets. Yes or no? Are you understanding the concept? Tell me, right? Now tell me, what are the number of options do you have? Think about it. What are the number of options do you have? Right? Let's see. Option number one, choose both apple, right? From one apple from basket one and one apple from basket two. Yes or no? Right? Second option, choose apple from basket one and banana from basket two. Option three, choose banana from basket one and apple from banana two. Option four, choose banana from both the options, both the baskets. Right? Yes or no? Tell me yes or no. Think about it. Right? Since we already know permutation, combination, and basic principle of counting, I hope all of you understood this. Okay, right? Now, how can we write it, right? Since I'm just choosing, and when you talk about mathematics is multiplication, so if I'm choosing apple in both, right, I'll write it as a square. Yes or no? Yes or no? Okay, right? I'm choosing apple and ball, sorry, apple and banana, AB. Here also BA, and this is B square. Now think about it. If I ask you in how many ways I'm choosing both apples, tell me in how many ways I'm choosing both apples or only apple. Tell me in how many ways? One way, yes, right? One way. Okay. In how many ways I'm choosing one apple and one banana? Two ways. Makes sense? Two ways, right? One this and one this. Okay. And in how many ways we are choosing just bananas? One way, right? So I hope if I have to consider, I can write like, okay, one way for both apple, two way for one apple, one banana, and one way for just banana. Yes or no? Tell me yes or no, right? I just gave a basic idea, okay, about this option, right? Instead of just multiplying, I'm just using a different concept, right? Because it might seem easy for this case, right? Because we have only two baskets. So it is easier to multiply rather than to think like this. Now just increase the number of baskets. Okay, instead of two, let's have, suppose I'm having five basket, right? I'll just take five basket. Okay, just think about it. A plus B to the power 5. Okay, 5 baskets. So it is A plus B into A plus B. Now, can we extend the same concept over here? Tell me, can we just extend the same concept over here? Think about it. Yes. Now, in this case, do you think that this method is easier than just multiplying? Yes or no? Yes or no? Right? No or yes? Now let's think. Suppose you have to choose, right? Only apple, right? Case one. Case one. Okay. Only apples. Only apples. Now think about it. How many fruits you have to choose? First of all, how many fruits you have to choose? Because you have to choose one fruit from every basket. How many fruits you have to choose? Five. Okay, very good. Five. Now out of that five, you have to choose only apples, right? So how many apples you can choose? Right? If you have five baskets and you have to choose five fruits, okay, right? So obviously you have to choose apples from all the basket. Got it? Now, in how many ways you can do that? Tell me, in how many ways you can do that? In how many ways you can choose, right? Five apples one way only, now, because you have only one option. Yes or no? You have to choose apple from this as well as this as well as this as well as this as well as this. So you have to choose apple from all the baskets. You have only one option, right? So one option for all the apples. Got it? Yes or no? Tell me. Right? Okay. Now case two. Okay, case two is you have to choose one banana and four apple. One banana and four apple, right? Okay, so it is either you can choose apple or you can choose banana, because the other one will automatically be choose, right? Yes or no? Because in any basket you have only two fruits. Yes or no? Tell me. Think about it. Yes or no? Right? Suppose you are not choosing apple from this basket, so obviously you have to choose banana. Okay, so yes, so suppose you are choosing one banana and four apples. So I have to choose like this, B or a to the power 4b, है ना, a to the power 4b. Yes or no? Right, everyone? Okay. Now, in how many ways, think about it, in how many ways you can choose four apple out of five baskets? Think about it. in how many ways I can choose 4 apple out of 5 baskets. In combination terms, you can say, Snigdho, right? In terms of combination, right? Try to write in terms of combination. I hope all of you remember the concept of combination, right? You have to choose 4 apples out of 5 basket. So what is the number of ways? Don't you think that it is 5C4? Yes, which is equal to 5, but it is 5C4, right? Yes or no? Yes or no? I hope all of you are recalling the concept of permutation combination, right? If you have to choose 4 things out of 5 things, it is 5C4, right? Then someone might ask, so what about banana? As I told you, suppose if you're choosing, right, this apple, this apple, this apple, and this apple. So automatically from this, banana will be chosen. You don't have to worry about that. Yes or no? Right? Got it? Okay. Now, what would be the case 3? Tell me, what would be the case 3? What would be the third case? It would be 3 apple and 2 bananas. Yes or no? Yes or no? Right? Now think about it. In how many ways you can choose 3 apples? Out of 5 basket. Very good, Snigdho. Very good, Afaq. Very good, Pragna. Very good, Varun. 5C3. Very good, everyone, right? So all of you are getting this concept? Yes. What would the next case? 2 apples, 3 bananas. In this case, tell me, in this case, in how many ways you can choose 2 apple? Yes, very good. 5C2. Okay, very good. Then 1 apple and 4 banana, and 0 apple and just bananas. So it is 5C1 and 5C0. Now if you think about this, this is also 5C5 now. This is also 5C5. Now are you like feeling that okay, this is quite easy concept, right? Doesn't matter if I'm given 5 power or 10 power, I can use this. Yes or no? If I'm using the concept of permutation and combination, right, this seems quite easy, right, everyone? Think about it. Okay. Now, someone might ask, so why we are just choosing apple? Why not we are choosing bananas, right? Let's see. Let's choose bananas, right? So if you are choosing bananas, what will be the number of coefficients? Suppose I'm just choosing bananas, right? So all the bananas, how many options? One option, which is 5C5. Same concept, right? Okay. Then 4 bananas, 1 apple. 5C4. Same concept. 3 bananas, 2 apple. 5C3. 2 bananas, 3 apple, 5C2. Now, I hope all of you remember that we have a concept which is 5C5 is equal to 5C0. I hope all of you remember this. NCR is equal to NC n minus R. Yes or no? Right? So 5C0, see, coefficient of B5 is 5C5 or 5C0. Both are equal. Yes or no? Right? Both are equal. So this is equal to this, right? 5C4 is actually equal to 5C1. So ultimately both, right? Both the arrangements are same. Okay, got it, everyone? Tell me, got it? This concept? Tell me, everyone got this concept? Yes or no? Everyone. Smarnika, Preeti, Ankit, Ananya, Abhilash, Anga, Maurya, Jaita got it, Navya, Neha, Pravalika, Shankar, Shreya, everyone is getting? Yash, Zaim? Okay, very good. Right? Okay, so I'll just rub this. Okay, now can I extend this concept? Okay, I'll tell you one more interesting method, right? Which is basically the derivation of this. Now, can I extend this concept as suppose I'm having A, plus b to the power n, right? Okay, or instead of n, I'll just take one more example. Okay, instead of n, I'll just take one more example. I'll take 8. Okay, now think about it. Think about it. First of all, instead of writing the coefficients, let's write the terms. Okay, let's write the terms. So first term would be 8 to the power 8, all the apples and 0 bananas. Yes or no? 8 apples, 0 bananas. First term. Plus second term, 7 apple, 1 bananas. 7 apple, 1 banana. Third term, 6 apple, right? 2 banana. Fourth term, 5 apple, 3 banana. Then 4 apple, 4 banana. Then 3 apple, 5 banana, right? Okay. Then 2 apple, 6 banana. 1 apple, 7 banana, right? And 0 apple and 8 bananas. Now think about this. How many terms do we have? Tell me. How many terms do we have? Add. Tell me how many terms do we have? Count it. 9. Okay, we have 9 terms. And what is the power? What's the power? 8. So can you observe that, okay, when we had power 2, we had 3 terms, right? When we had power 1, we have 2 terms. When we had power 3, we had 4 terms. When we are having power 8, okay, we're having 9 terms. So can I say that if power is n, the number of terms will be n plus 1? Tell me, number of terms will be n plus 1? Yes or no? Because it is 0 to n. And 0 to n. That's why we have n plus 1 terms. Okay. Right? Step by step. Everything is easy. Step by step. Right? Now let's talk about the coefficient. Now we have 8 baskets. 8 baskets. And out of 8 baskets, you have to choose 8 apples. So I can say that the answer would be 8C8. Right? In terms of apple. Yes or no? Right? Or in terms of banana, it will be 8C0. In terms of banana, it will be 8C0. Okay, I'll write 8C0 with different color. Okay. 8C0. Now, we know that 8C0 and 8C8 both are same. So it doesn't matter. Both is 1. Okay, got it? So this is in terms of bananas. This is in terms of apples, right? But ultimately it is the number which is same. Now, when you talk about this, right, the coefficient will be what? 8C7. Yes or no? Right? Step by step. It is 8C6, 8C5. I'll just change the color for coefficients. Okay. 8C4, 8C3, 8C2, 8C1, and 8C0. Got it, everyone? Right? So, okay. Now, don't you think that this is literally quite difficult to write all the time, right? If I'm having a plus b to the power 11. So obviously there should be a short way to write it. I should not write all the 12 terms. Yes or no? Right? Think about it. Yes or no? Because it is what? It is just the addition, right? Yes or no? It is the addition of different terms. So if I can find a short form or short method to write it, right? How to write it? Now, tell me, tell me this. If I pick any term, just pick any term, right? Suppose pick this term. I'm picking this term, right? This term, just pick this term. So if I observe this term, right? What is 8? 8 is the power, yes or no? 8 is the power, okay? C. Now let's see 5. What is 5? 5 is, suppose, your this coefficient, right? This coefficient. So can I say that? Can I say that? Okay, right? Suppose 5 is r. Okay, some coefficient. So can I say that? Okay, it will be a to the power r into b to the power. What is 3? Tell me, what is 3 in terms of n and r? Can you tell me? N minus r, right? Now, don't you think, okay, and put n is equal, put r is equal to n, put r is equal to 8, right? Put r is equal to 8. I'll get what? This first term, right? Or instead of that, okay, instead of that, can I write it like this? Okay, right? Doesn't matter, right? Because in this case, I'll put r is equal to 0. Yes or no? Okay, right? So you can write in any way. Okay, you can write in any way. Now, suppose instead of r is equal to 8, instead of r is equal to 8, if you put r is equal to 0, then what you'll get? Then also you'll get this last term. Yes? Okay? Think about it, right? Then last term. Now, suppose instead of this, if formula is written like this, NCR a to the power n minus r, b to the power r, right? Then both are same, right? Both are same. Yes or no? It's just that it is starting from a to the power 8, b to the power 0, or 8 to the power 0, b to the power 8. Got it? Tell me, got it? Right? It is starting from this side or this side. That's all is the meaning of this power. I hope all of you understood this one, right? So both of them can be called as general term. General term. Anyone have any issue in this? Tell me, anyone have any issue in this? Clear? Right? It is just matter of counting. Now, either I'm counting from this side or this side, or I'm just considering starting from a to the power 8, b to the power 0, or a to the power 0, b to the power. It doesn't matter, right? Okay, right? Now, okay. So if I'm saying that suppose this is your, I'll just write it down. This is your term. Okay, this is your term. I want to find fourth term. Fourth term. Now tell me, for fourth term, what should be the value of r? Think about it. If I'm considering this case, right? For fourth term, what should be the value of r? Think about it. 5, na? 5. Got it? 5. Okay? Right, everyone? Okay, now this is just for understanding, right? This is just for understanding. I hope all of you understood this. Okay, now by convention, there is a convention, right? By convention, okay, we will consider it with respect to B. Okay, so according to convention, I'll just write it as like this: NC0, A to the power N, B to the power 0. Sorry. Okay, right? This is by convention. Okay, guys? This is according to convention. Okay, plus NC, because 8C8 can be written as 8C0 also, na? So by convention, the order is with this NC0, NC1, NC2, right? This is just a convention, but obviously if you understood the concept, it doesn't matter, because 8C8 is also 8C0, 8C7 is also, I'll just write the coefficients here: 8C1, 8C2, 8C3, 8C4, 8C5, 8C6, 8C7, 8C8. Okay, so this is just a convention. Convention means usually book follow this. Okay, got it? Because they have to follow one representation, na, right? So in order to have consistency, they represent using this. But I hope all of you understood that doesn't matter if you're using this or this, both are same. Yes, got it, everyone? Got it? Tell me. Okay. Now, suppose I'm using this. Suppose I'm using this. Still, the formula will be same, na? Right? NCR. Think about it. NCR. Suppose this is R. It is what? A to the power n minus R and B to the power R. This is what I said. The second one. Got it? Okay. Now tell me, if R is equal to 0, then it is which term? If R is equal to 0, then it is which term? First term? Yes or no? If R is equal to 1, right, then it is second term. So this is the reason why it is written like this, because it is comparatively convenient. Okay, right? Comparatively convenient. Because if I'm saying R is equal to 8 is equal to n first term, then it sounds some bit confusing to some people, right? Okay, if you know the concept, then it won't be confusing, but it might sound confusing. But this makes sense. 2, that is third term. So can I say that nth term is equal to r plus, or rth term is equal to r plus 1, right? Okay, tell me, if I have to find fourth term, it will be, r value will be 3. Got it? Anyone have any issue? Tell me, anyone have any issue in this? Raise a hand. Or all of you understood? If all of you understood, please let me know. Yes? Okay, very good. Right? So I hope all of you understood this. Okay, now let's see. Let's see one more interesting thing. I hope I have told you this, or if not, then you might have studied or read somewhere. How many of you, how many of you have seen this? Tell me. Raise your hand. Think about it. This is called as Pascal's triangle. This is called as Pascal's triangle, right? Now, if you see this, right, and if you try to, okay, right, observe. So 1 plus 1, 2, right? Now 1 plus 2, 3, 2 plus 1, 3, 1, 1. Then 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4, 1, 1. So we are adding the two terms. Yes or no? So it's like this. This plus this give this. This plus this gives this. This plus this gives this, right? In the same way, this plus this gives this. This plus this gives this. This plus this gives this, right? And so on. Yes or no? Tell me, yes or no? Right? Now, this is a very interesting triangle. This is called as Pascal's triangle. It has many properties, right? If you try to observe the property, then see what is the first term. First term is what? 1, right? So let's see some properties. First term is 1, 1, 1. So first thing that what we want to observe is, it is what? A plus b power 0. I'm talking about the coefficients only, right? Just think about the coefficients only. A plus b to power 1, a plus b, a plus b whole square, a square plus 2ab plus b square. Yes or no? Can you observe? A plus b whole cube, a cube, 3a square b square b, 3b square a, or ab square, a b square, and b cube, right? If you observe this, a plus b whole power 4. See, 8 power 4, a cube b, a square b square, ab cube, b cube, right? A plus b whole 5, a5, 4b, this a cube b square, a square b cube, ab power 4, b power 5, right? Got it? Yes or no? Got it? Yeah, b power 4, sorry. Now, don't you think that this is again the same thing that we did? Yes, right, everyone? Now, if you observe this, then someone might be confused in NPN and sorry NCR, NCR minus R. But if you see this, then you can actually observe, right? You can actually observe that the coefficients are equidistant, right? What is the meaning of coefficients are equidistant? Tell me. What is the meaning of coefficients are equidistant? Means, right, if you talk about terms from start or end, the coefficients are same. Okay, the coefficients are same. Yes or no? Right from here, second position, right? Got it? Yes or no? Yes or no? Then if I ask you, where is the what is the position of what is the position of highest coefficient? Tell me, what is the position of highest coefficient? Observe and let me know. Middle, right? Got it? Yes or no? Everyone agree? Yes or no? But again, we have a catch. What catch? It depends on number of terms, because if we have odd number of terms, then we have one middle term. But if I'm having even number of terms, we have two middle term. Yes or no? Right? See the pattern. Got it? Yes or no? Okay. So let's think about this. Suppose n is equal to 2, which is this case. What is the middle term? Tell me, what is the middle term? Which position is the middle term? Tell me which position? Second position. So can I say that? Okay, it will be, right? It will be what? N by 2 plus 1. Yes or no? N by 2 plus 1. As simple as that, right? Talk about this position, right? So it is even. When n is even. Talk about n is equal to 4. Talk about n is equal to 4, this one, right? Which position is the even position? So it is what? 4 by 2 plus 1, which is third position. Yes or no? Yes or no? Right? Okay. But when you talk about odd power, okay, think about it. When you talk about odd power, for example, this one, 3 power 3. So when you talk about odd power, number of terms will be even now, because number of terms is n plus 1. So if n is odd, then n plus 1 is even. Yes or no? So if you think about this, right, I cannot say that n by 2, because n by 2 will not give me something. So what I should say? I should say n plus 1 by 2. Yes or no? So what is n plus 1 by 2? Tell me. What is n plus 1 by 2? Which position? 3 plus 1 by 2, right? Second position, right? But since we have 2, So it is n plus 1 by 2 plus 1 also. Got it? So it is second and third position. Second and third position. Yes or no? I hope all is understood, right? So it is, don't you think that this is like median? Don't you think that this is like median? The formula is also same as median. Yes or no? Even number of terms, then median is n by 2 plus 1. Odd number of terms, then median is n plus 1 by 2 and n plus 1 by 2 plus 1. Right? Got it? Okay, I hope all of you understood all the concepts till this point. Yes or no? Raise your hand. Everyone should understand. Yes? Agree? Okay, very good, everyone. So let's see. I hope all of you understood this concept, right? This understood? Okay. Pascal's triangle, we understood. We studied Pascal's triangle also. Okay, very good. Very good, everyone. Okay. Now, this is the terms that we just discussed. So I told you that according to convention, write like this. Got it? Yes. So this is according to convention. Okay. Right? We already proved in a much simpler way. Instead of multiplying, we just put in a simpler way. Right? Now, this we have done. Now think about it. Right? What are the things that we have to observe from here? Now, if you talk about the term, the short form, can I write it like this? Tell me. Can I write it like this? As I told you, it is NCR a to the power n minus r b to the power r. Yes or no? Right? So it is summation. Now the value of r starts from 0 and till n. So put r is equal to 0, you will get first term. Put r is equal to 1, you will get second term. Put r is equal to 2, you will get third term. Yes or no? Right? So this is a short form of writing the whole expansion. Okay, got it? Right? Now, some special cases. Now, these special cases are basically just the variation. Okay, it's just the value. For example, if I'm having x minus 5, do you really need to remember any other formula for that? No, nah. Just put right y as minus 5. Okay, yes or no? Y as minus 5. So whenever the power of y will be odd, it will be negative, and whenever the power of y will be even, it will be positive. Yes or no? Right? So instead of A, B, you can put anything. Okay, you can put anything. Okay, and you'll get the expansion. Right? Now, let's try to solve this one, guys. Everyone, try to solve this. Easy question. Try to solve this. Take your time. Try to solve this. Done, everyone? Done? Tell me. Step by step, just put the value x square in place of a and 3 by x in place of b. That's it, right? That's what you have to do. Okay, let's see, right? Let's see one problem step by step. Okay, now let's see this. It is just as a formula, right? I'll just show you step by step. So the first term, write it down step by step. First term is what? Power is 4. So coefficient, start with coefficient. First coefficient is 4c0. Okay, right? Now a is x square to the power n minus r, 4 minus 0, right? Got it? Yes or no? Into b to the power 0, which is 3 by x power 0. So I'll not write it. So what is the first term? It is 4c0 x power, tell me, 2 into the power 2 into 4, 8. Got it? First term. Second term, 4c3, sorry, 4c1, right? 4c1, okay, x squared to the power 3. So x power 6. I'll just write it directly, okay? And 3 by x to power 1. So I'll just write 3 by x directly. I hope all of you can write it down. So 4c1 is 4, x6, 3 by x. So we'll get x power 5. I hope all of you are getting now. Plus 4c2, x to power x square power 2, which is 4 into 9 by x square, this power 2. Plus 4c3, x to the power 1. So x square to power 1, x square into 27 by x cube, plus 4c4, right? It is power 0, and this is 81 by x power 4. Got it? Tell me, got it? Everyone got this? Yes or no? Raise your hand. Yes? Okay, very good. Now, can you find this 98 to the power 5 now? Right? I hope all of you can find 100 minus 2. Okay. Okay. No, Anya, but starting, if you're right, then you won't make mistake. Otherwise, sometimes we tend to make mistakes. Okay, you can just write directly also. Okay, now this problem, question number 3. Everyone try to think. Question number 3. Everyone try to think. Question number 3. Without solving, can you tell me which is bigger? Think about it. 10,000 or 1.01 to the power 10 lakh. Okay, very good. Everyone is saying 10,000, right? Okay, one student saying this. Now think about it. Just think about it. What is this? It is 1 plus 0.01 to the power 10 lakh. Yes or no? Tell me, yes or no? Yes. Now what is the expansion? Tell me, guys, what is the expansion? It is 1 into 1 to the power this total big number n into 0.01 to the power 0. Okay, plus, now that's the catch. What is the second term? Second term is n into, remember nc1 is n into 1 into 0.01. What is n? Tell me, what is n? N is 10 lakh. Yes or no? 10 lakh into 0 or 0.01. Now this itself, the second term itself is equal to what? Tell me. The second term itself is equal to 10,000. Yes or no? Think about it. Think about it, guys. The second term itself is equal to 10,000. And we know this, right? We know this. We have another multiple terms. Now, don't you think that this is much larger than this? I hope all of you got the concept now. Tell me. I hope all of you got the concept. Okay, now let's see example 4. Okay, everyone just focus on example 4. How good this problem is, example 4. Now see, this is called the critical thinking problems. Okay, critical thinking problems, example 4. I'll give you 2 minutes, try to think. All of you can solve, right? Because whatever is needed to solve this, all of you already know. So think about it. Think about it, guys. Or should I give you hint? Hint? Tell me. Hint is required. Okay, the hint is this. 6 can be written as 5 plus 1. That is a hint. So that is the difference between class 10th and 11th, right? This is just 4th example. Same concept, right? No new concept, right? Okay. Basic formula and basic division concept. Still, the problem seems like difficult. Yes or no? Think about it, right? And it's not that this is science or commerce or arts, because this maths is same for everyone. This is basic NCRT. Think about it, guys. Anyone? Anyone who proved it? Kushagra, Yashika, Sujan, Dhruv, Omkar, Navya. Anyone who proved it? Afaq? The Kushagra is absent. He is not even attending the class. See, that is the guys. You guys are scared of taking approach, right? Just do it, na? Yes, very good, Snigdho. Just do it, right? Don't hesitate. Just do it. 5 plus 1 to the power n minus 5n. Expand it. What is the formula? Right? Expand it. It will be easy. It will be what? nc0, right? 5 to the power n. Yes or no? Plus nc1, 5 to the power n minus 1, plus dot nc n minus 1, right? 5 squared. Sorry, 5 to the power 1. Okay? Into, tell me what? 1 plus ncn into 5 plus 0, 1. Yes or no? That would be the expansion. Yes or no? First term, second term, and last term and last term and second last term. That's it. Yes? Yes, everyone? Now, don't you think that if we talk about 25, 25 is 5 squared. Okay, right? So all the terms have 5 square in them except for the last term and second last term. Yes or no? Think about it. Except for last term and second last term, all the other terms will have 5 square in them. As simple as that. Yes or no? Yes, right? So this is your second last term. This is second last term. This is your last term. Now think about it. What is your second last term? NCn minus 1 is equal to n. Yes or no? NCn minus 1 is nothing but n, because NCn minus 1 is NC1, which is n. And 5 power n is 5, 5n. And what is this? NCn is 1. 5 power 0, 0. So it is plus 1, right? Minus 5 and it is given. So 5 and 5 and cancelled. This whole term except for this two term, right, is already a factor of 25, is also, sorry, multiple of 25, right? 5 and 5 will cancel. So obviously we are left with 1 only. So the remainder is 1 only. Think about it. Was that very difficult problem? Was this very difficult problem? Ask yourself. Okay. I hope all of you understood this concept. Yes or no? Just raise your hand. Okay. Okay, so we are done with this. So if you guys got time, right, try to solve these problems. We have only 14 problems. Okay, general and middle term we have already discussed. General term and middle term we have already discussed. So if, because again, I'm not saying anything is compulsory, but you can just go through the examples. I'll tell you, either just go through example number 9, right? Solve all the example number 9 and 8.1, right? Just go through it. I will discuss these two in the next class. Okay, got it? You have 1 week, right? Okay, and today, as I said, after 5 p.m., I'll give one objective, easy objective test of 10 questions only, just for revision in physics. Okay, right, everyone? Okay. Okay, bye everyone. Thank you. I hope all of you understood all the concepts, right? Okay, bye everyone. Thank you, everyone.